right, our next lesson is going to be with the number line, and hopefully when we're done, I should be able to give you a number and you should be able to put it on the number line where it belongs. Now first of all, you might be asking yourself, what is a number line? A number line, if you just think about it a little bit, is a line first of all. So let's just draw a line. Either I ate too many weeds for breakfast or this chalk is getting weaker. So there's our line. Now, in order to get a number line out of that, you need to choose 2 points. And you just basically close your eyes, and I'll look so I get it on the line, but you basically close your eyes and you say, okay, there's 1 point, and you put 0 above that. Then, arbitrarily, anywhere to the right of that, you choose another point, and that's called 1. Now, the minute you do that, the distance between these two is called a unit. And that's what determines everything else on your number line. So if someone said, locate 2 on the number line, what I would do is think of addition, and I get 2 by adding 1 and 1. So I take this unit, I add that onto the 1 that's already there, so that this point becomes exactly the one that corresponds to the number 2. And if I wanted 4 on the number line, then I need to go 1, 2, 3, 4, and there's the home for 4. We also found the home for 3, so we might just go put that on. Now, so far, the numbers I have on here are called whole numbers, and those are the numbers 0, 1, 2, 3, 4. Just keep going, 5, 6, 7, 8 indefinitely. If you just look at the numbers that are on there without the 0, that is called a set of natural numbers. Now, there are other numbers as well that exist to the left of 0. And suppose somebody said, locate -2 on the number line. All right, -2 is 2 units to the left. So we take our unit and we go 1, so that's the home for -1, and right there is the home for -2. So we are able to put the natural numbers on the number line, the whole numbers on the number line, and now we have the availability of putting all of the integers on the number line. That's adding our negative numbers here. So now this number line has all of the integers on it. If I wanted -3, for instance, I would find it over there. Even though we don't have them all listed, they are there by just moving my unit around the appropriate number of times. I will mention this because you might be interested in it. Hopefully you're interested in it. We are eventually going to put rational numbers on here, which means fractions and so on. And you need to know a little more geometry than we know right now to do that. But eventually we will put those on there, and then in another year we're going to put numbers like square root of 2, square root of 3, numbers like that, which are called irrational numbers. We will be able to find the exact home for them on our number line. Now, we made this first number line. What would have happened if we chose 0 here and 1 there? How does that change things, do you think, on our number line? What would be your guess?
Would make the units larger.
Wonderful, that's a perfect answer. It would make the units larger. You do the same thing to find 2. You measure the unit, and good thing it wasn't any further, I wouldn't reach it. And there's 2. And there's 4 way out there. -2 would be down there, and so on. It just makes the units a little bit larger, and if you pick 0 and 1 a little closer together, it squeezes things onto your number line a little bit. But relatively, they're all in the same relative position to each other. Now, one of the other things that we need to know in mathematics is which numbers are bigger and which numbers are smaller. And sometimes that's pretty difficult. Suppose we take the numbers 2 and 4 as an example. Hopefully we know the answer to this already. Which of these numbers is larger? 4 is the larger number. And in mathematics, we use a symbol that looks like that to say that 4 is larger than 2, or if we read it the other way, the way we normally would read in English, 2 is less than 4. When you're dealing with natural numbers or whole numbers, choosing which one's larger is pretty commonsensical. You've got a pretty good feel for that from your past math. Let's suppose we put -1 and 2. Would anyone like to guess which is larger there? 2 is larger again. Do you know why it's larger? Can you get a feel from our number line why it would be larger?
It's on the right side of 0.
Okay, it's on the right side of 0. It's also on the right side of -1, isn't it? That will be important in a moment. So again, the symbol happens to go in that way that -1 is less than 2 or 2 is larger than -1. Let's take two negative numbers just for kicks. We have -3 and -5. Which of those two is larger? And this is not common sense necessarily here.
-3.
-3 is larger. Very good. -3 is larger. So the symbol would go in this way. And can you use to the right of and to the left of like you did earlier?
No, but it's closer to 0.
It's closer to 0, okay. Which one of these numbers was to the right and to the left in this one? Adam, do you want to answer that?
2 is on the right.
2 is on the right, okay. Of these two, which one is on the right?
-3.
-3 is on the right. So the number that's largest, the larger of the two, is always to the right. The smaller of the two is always to the left on the number line. Now, this is a little bit dangerous, ladies and gentlemen, because sometimes our number line looks like this.